Green propellant to me is a way to reduce the cost, the overall program and mission costs for attitude control for spacecraft, because we get rid of all of the environmental hazards and dangers associated with hydrazine. One of the great benefits, performance-wise, of this propellant is the ISP on the engines is a little bit better. We actually are looking at about a 40% increase in density ISP improvement with this type of propellant. Well, by having this, if you have a given tank volume that you don't want to change, suddenly you're getting a 40% increase in the mission life from the amount of propellant that's in there. Or you can bring down the size of the tank, put on more payload and things like that. The real area we're trying to save money in is in the loading. In a sense, you can take this stuff, pour it into a funnel into the tank, cap it off. Of course, we won't be doing it that simply, right? But you could do that with this propellant. Whereas hydrazine is hydroscopic, it'll pick up moisture as a contaminant. This stuff does not do that. It has a broader temperature range. It's easier to employ in the spacecraft because you can have wider temperature variations and not have any issues with the propellant itself. So you're really looking at having enhanced capability for an ESPA class or a small sat rideshare payload that comes off at that point in time in the mission. We're adding propulsive capability to that, which enables a lot of technologies to be demonstrated that would not otherwise be. Another advantage of having this is enhancing the deorbit capability of this spacecraft. We got a 25-year requirement now. Well, by having this propulsion system on there, we can potentially go at higher orbits and do different types of experiments we couldn't have before, and then bring it in and meet the 25-year deorbit requirement for orbital debris. The costs are going to be very similar, if not the exact same, and we are saving a ton of money on the handling, loading of this stuff, and a lot of the safety issues associated with hydrazine. Right now you have to suit up in full bunny suits with air conditioning tubes coming in to keep the clean air flowing. You put on a mask here like you're at the dentist office, so you're not getting anything contaminants in there, and you handle the stuff with gloves in an open room environment. A lot safer. And then the real savings would be getting rid of all that processing at the launch facility, taking the propellants back, loading them at the spacecraft manufacturers, and we can ship these. We're launching in 3 years. Right now our target vehicle is STP-2. The first portion of the program is focused on the work that Ball is doing with Aerojet, maturing the technology of the engines. Once Aerojet has completed development of this technology, which includes tanks, valves, thrusters, especially the thrusters, they're going to build that up as a payload assembly. Comes to Ball, gets integrated. We do the environmental testing, final checkout at Ball. If we can really pull it off, we'll fuel it up at Ball, and then we'll ship it off and have it integrated as a secondary payload.